Salam and good day. So in these topics, we are going to learn about the interrupts, which is a process that a controller can do while doing the main process at the main function. So it's a mechanism where a microcontroller enable to respond at the events at the moment when they occur, which is the interrupts, regardless of what microcontroller is doing at the time. So just to make it very simple, just to make it easier, when you're running a microcontroller, right, you have the main body, main functions, and then in between these main functions, right, if you already set up an interrupt to be used in the programs, so whenever in this process doing in the main program, you can just do the interrupts, and the microcontroller can stop for a while and do the interrupt functions, and then later coming back to the main program. All right. So there are three types of interrupt sources in microcontroller, but for this particular video, I'm going to only talk about one interrupt here, and the other two will be talking in the other videos. So I just want to introduce all the three first. All right. So the first one is this one. They call it the external interrupt on pin RB0/INT. This is at pin number 33. All right. And then you have the second one, which is a timer 0 counter overflow. Okay. The third one name is which is also the external, change on pin from RB4 to RB7. This is change on port B. Port B change, right? So it's something like this. So the difference will be, okay, so this case and this case, both are external interrupt. And for the timer 0 counter overflow, this is the internal interrupt, where this one will be based on the clock inside the controller, whereas these two interrupts are waiting for the signal outside, where you can put like a switch or whatever to activate the interrupt. Okay, so you can use a switch. Later you are going to use a simulation to look at the example of RB0 later in port B changes. All right. In micro C, this is your software. All right. Recognize an interrupt routine to be executed as the void interrupt. This is the function for the interrupt. No matter what, if you want to use the interrupt for the microcontroller using micro C, you must use these void interrupt functions. It must be spelled correctly. It must be used the same thing, and it cannot be used for any other functions except interrupt. So last lecture we learned a bit about the functions, right? So you have the void, this is your name interrupt, and you have the bracket here, open and close, and later you're going to have the curly bracket open and curly bracket close. So this is going to be your interrupt function inside. You can write anything that you want to have the interrupt. So this is the full function for the void interrupt, and it is only for the micro C programming. All right. So example of an internal interrupt. This is like the RB0 just now. You have the switch. You can be a switch over here, and this switch will behave like something like input to the PIC, and then as a signal to start the interrupt. So when this thing is pushed, right, so you can see that the program execution flow, which is normally in your main body, let's just go have a look over here in your main body over here, right? Let's say you have a program here, right? You are going to have this one running, and then in between, when you hit the button at the at the switch over here, it will give a signal. This is a low signal, and then it will execute the program in the interrupt functions because the interrupt had happened. Okay, so this is where and how the process look like. So you have the process execution, you have the interrupt, this is running, and then finish the interrupt, and you can go back to the normal flow in your main program. Alright. So right now, the register that you need to understand, it's called incon registers. Previously, we learned about registers like trace this one. This is a register, and then you have port. This is the normal registers that we learned before to set up your pin as your input output, and also to give a level voltage for the pins where after you already set up as your output. So today we are going to learn another register. They call it incon, which is the short form for interrupt control register. This is incon. Alright, so you have to read and understand if you are given a manual like this, because if you look at the manual from the PIC 16F, you can search for the incon registers. So registers size is 8-bit size. Same goes to trice. You remember that you have the 0B, 0000 example here, 0000. So this size is 8-bit. Same goes to incon. You can see that here from the explanation over here, we have 8-bit of size. So this is 1, 2, 3, 4, 5, 6, 7, 8. So 8-bit of size. So all the registers are 8-bit of size. So it's very simple to just make sure that you are not don't overthink that more than 8. So just make it you understand that it's 8-bit of size. So each of the bit here, right, is defined by here. So the purpose of this register is to set up your types of interrupts that you want to use, or also I can say that you are going to allow or disallow the interrupts that you want to use in your program. Alright, so let's look at one by one here. We have the GIE, we have the PEIE, timer 0 IE, in E, RBIE, timer 0 IF, INTF, and RBF. So the explanation will be like this. So you have the 8-bit size, right? Inside the every bit of the register, you are allowed only to give 1 or 0. That will be only the value like this, 1 or 0. Alright, so look at the explanation first. So bit number 7 GIE, this is a global interrupt enable bit. So if you put 1, it will enable all unmasked interrupts. So you have 3 interrupts. So if you want to use it, you must put this one as 1. Alright. So you are going to read next one is a peripheral interrupt enable bit. You are not using it. Timer 0 overflow later. RB0 RB0 interrupt external interrupt enable bit. So we want to use this one. RBIE later. Timer 0 later also. INTF, RBIF. So okay, so this is IF, is a flag. We are going to discuss this one later. But to enable or to set up which type of your interrupt, you are going to set this one. PEIE, timer 0 IE, INTE, or RBIE. So for this case, the first one that I'm going to use is RB0. Alright. RB0 is the bit number 4 here. RB0/INT interrupt. So you are going to set up bit number 4 as 1. So the rest will be 0. So if you want to select the RB0 interrupt, so you're going to set up your incon register is equivalent to 0B 1001 0000. So this is your command to set your interrupt using the RB0 external. Okay, so that is the example. So before we proceed on that one, I just want to tell you guys that each of the interrupt must have its flags. Flags. It's just like this, a flag. Okay, it's a flag. Something that the system will flag and tell the process it must go to the interrupt functions. So this is a pair where, for example, that if we are using the INTE, the one that RB0 just now, this is RB0 interrupt. We are going to look at the INTF. This is interrupt flag. F for flag, right? So right now, when interrupt happens, right, this INTF will set to 1. And the system will check if the INTF is already 1, so you have to go to the function of the interrupt and execute whatever things is inside the interrupt functions, finish it, and then go back to your main line. Okay, same goes to the others interrupt. So what you are going to concentrate here for the INTE and INTF. So originally you are setting up this one, right? So after interrupt happen, the incon register will change to 0B1001 0010. This is this bit number 1. This is INTF RB0/interrupt external interrupt flag bit. So if the interrupt happens, then you are going to look at this one, and the execution of the interrupt must be followed, finish it, and then go back to your main line. Alright. Let's look at how we works on that. So you have your Proteus first, right? And then of course you have to set the switch for the RB0 here. Let's just run this one first. Your switch is okay. Okay, so your switch is working now. So it means that if you want to do something, you're going to do this interrupt and do something else. Let's say, for example, that I want to do if a security system, right? So let's say I put this one as a sensor at the window. So if the window is broken or hit, and then I'm going to turn on the LED or the siren or the buzzer. So it's just something, that example that I want to use. We just use LED. Alright, so we just use the very easy one to look at. So at the moment, I don't want to use the resistor, because I just want to make the light brighter, because if I put resistor, the light is not going to be it's going to be dim is going to be. So we have the ground here, and then just connect everything. So I just want to use spot C here. Alright. Okay, just to want to make sure that your system is working. Cool. Okay. We just want to change this one. So this is your void main. When you start your program, you're going to set up your. Okay, let's look at this one. So this is going to be your input. So thrice B is equivalent to 0B00000001 semicolon. So this is correct. I'm setting up this one as my input, and then this 4 is going to be output, because I'm going to send up the signal out from this one. So try C is equivalent to all output. So it's very easy to write down that one. And then later we are going to have the while one loop here. You start this one, you have the curly bracket open, and you have the curly bracket close. So we are going to turn on the LED over here. Port C is equivalent to 5, which is 0B 1111 1111 and semicolon. So let's look at the result first, just to make sure that your code is working fine. So we're just going to build this one, no issue. Alright, so we have this one, and then we run this one. Turn this one, RB0 open. This one's going to be 20 megahertz. Then okay, then just run this one. You can see your LED is working correctly. So this is just to double check your circuit. Right now, the input is still correct, right? It's red color because this is high voltage. So if we push this one, then it will turn blue because this is a 0 volt. Once the button is pushed, and it will refer to the ground, and it has a 0 volt over there. So let's just change again this one, just make it as by default there's all the LEDs are all 0. Okay, so this is the main function. If you want to use your interrupt, right, you must create another function called void interrupt. So void interrupt here, spell must be correct, bracket, and then you have the curly bracket open, and then you have the curly bracket close, right? Okay, here will be your, what you call it, this here will be your functions for the interrupt. So for the case of security system, right, if anything happen, you can turn on your LED over here. So I can stop this one for a while, and then we just want to go and put the code over here. So inside your main program, you have the port C is equivalent to 0B 1111 1111. So this is to turn on your port C. Initially it does not turn on, and eventually if the interrupt happens, you have this one. Alright, so just compile this one first. Just want to make sure that is it working or not, because we're going to look at the result one by one. So this is the latest one just now. Yeah, this is the latest one. And you just run this one, and you hit the button, there's nothing happen. Okay, there's nothing happen yet because you do not set the incon registers. So we are going to do the setup for the interrupt. So you can start to put the incon setup after you set up your input output. So here you can start with the incon registers to be set up. 0B, 1 is the first one, 001, 0000, which is the 4th bit you have to set to use the RB0 interrupt. Okay, so this is related to this one again. RB0 is this one, bit number 4. So you are going to enable external interrupt. You are going to put 1, enables the RB0/interrupt external interrupt. Okay, so you had set up your incon correctly right now. Okay, so right now, if your what you call that, the interrupt happens, then it will go up here. Whereas if the interrupt does not happen, it will always on this particular main body. So let's run this one. Okay, go back to your Proteus. Right. Now you can see the code. Now if you push the button, the interrupt happens, it will go to this one, port C. Alright, right now it's going only in this area because the interrupt happens. By right, you must go back to your main program. Okay, so that's the reason why if you look back at the slides here, you can see right now the pair for this one RB0, the pair will be the INTF. This bit is actually already been set because the interrupt had happened. So what you need to do is you need to clear back this bit to 0. Go back to 0. You need to change this one back to 0. So once you clear back this bit, right, the program will go back to its normal position here, the flow here, and then it will wait for the next interrupt to happen. So how to do that? In this case, right, you must change the bit by the software inside the interrupt routine. So here you can clear the flag by using this command incon.intf directly to the bit that you want to change, then you clear it as 0. So this command is to clear the flag for the interrupt. So later it can go back to the main program and execute this one. So I just want to make it a delay like this for maybe 2 seconds. So delay ms 2000, and then it will go back to this particular main line. So just build this one, and then you can run back your program. Now by default there's nothing happened to the LED. Somebody break into the house and give the switch active, then you have this one for 2 seconds, and then it will off, go back to this one, because you already have it here. You already cleared you already cleared the software, the flag over here. Okay, all right.